Okay. So this is the third dynamic protocol which we are learning today, and that is what OSPF, Open Shortest Path First. Can anybody tell me what is the protocol number for OSPF? Protocol number of OSPF?
89, sir.
Very good. And what about the ENCOR? 88. What about the RIP? 520. Version 1, version 2, both are using 520 under UDP protocol. Okay, and RIP NG, RIP NG, next generation, which we used for IP version 6, that use a protocol number 521. Okay, protocol number 18, classless or classful? Classless protocol or classful protocol?
Classless.
Classless or classful?
Classless.
Okay, so it is a classless protocol. That means it will always carry the actual subnet mask along with the subnet ID, along with the network ID, or you can say the subnet ID. Okay. Any idea about the administrative distance?
110, sir.
110. Okay. Administrative distance for OSPF is 110. Okay. For EIGRP it is 90. For RIP it is 120, and for static it is 1. Okay. So in OSPF the administrative distance is 100. Sorry, administrative distance is 110. Any else? Anyone? Any points? One second. Remember the points.
Metric is the cost.
Sorry guys, I got a call. What it is? Somebody saying something. Hello, am I audible to everyone?
Yes, sir.
Okay, somebody saying something. Yeah, I think you. Any points? Class-wise protocol.
Multicast
Huh?
005.
Multicast address.
Multicast address.
Very
Yes.
good. Multicast address. What is the address of? What is the multicast address which OSPF use?
005
5 and
and 6.
6. In some condition they use 6 also. Okay, but by default in every condition they use 224.0.0.5. In one of the conditions they use 6 also. So better to learn both 224.0.0.5 and 224.0.0.6. Anyone else? So I want output from you guys.
Equal cost load balancing.
Huh?
Equal cost load balancing.
Equal cost to load balance. Very good. Equal cost load balance. Equal cost load balance. Does not support any unequal cost load balance. OSPF do not support any unequal cost load balancing. It only support what? Equal cost load balancing. Metric cost. Okay, which is what? 10⁸ divided by bandwidth. Okay. Next.
Unlimited hop count.
Very good. It support what? Unlimited number of hop counts. Whereas EIGRP support up to how many hop counts? EIGRP
255.
255.
Very good. 255. Okay. RIP support up to 15 number of hop counts. 16 is reachable. Whereas OSPF support unlimited number of hop counts. Okay. Next. Let's tell me fast. Equal cost load balancing. Support summarization. Support summarization. Huh? Yes. Manual and auto both. It supports summarization. Manual and auto. Both is the summarization. Okay. Next. You guys better know about the summarization. EIGRP supports summarization. Manual plus auto summarization. RIP supports summarization. Use the concept of area. It use the concept of area. What is area? What is area? Yes, anybody can explain me what is area? Yes, anybody? Localized impact of topology change. It OSPF use the concept of what? Area. You can create an area from 0 to 4.2 billions of area. In the complete OSPF topology, you can create areas from 0 to 4.2 billions of area. Okay, what exactly the area means in OSPF? In OSPF, the area means the localized impact of a topology change. Localized impact of topology change. What exactly happens? Okay, so if suppose you have multiple routers and you decided to divide this complete topology in some areas or in some parts. Okay, So what you will do, you will create or you will put these two router in area number 1 and these two router in area number 2. Okay, so now what will happen if anything will goes down in area number 1? Okay, it will create a localized impact within an area 1. Okay, it will never cross its area boundary router, which is also known as ABR router, area boundary router. Okay, if anything happens in area number 1, it will remain in only area 1. Okay, it will never cross its area boundary router. Similarly, if anything will happen in area number 2, it will remain in area 2 itself. Okay, it will never carry its area border router and reach to area 1. Okay, that is why they came up with the concept of areas, localized impact of topology change. Okay, if anything will happen in router 1 or in area 1, okay, it will create only a localized impact. Okay, it will never cross its area border router. There are different types of router name in OSPF. Area border router. Okay, some are ASBR, autonomous border router. Okay, some are backbone router, some are regular routers. What is area border router? Which connect two different areas. That router is known as what? Area border router. Okay, so what exactly the area is? Area is which will create a localized impact within an area. Okay, if anything will happen, okay, it will create a localized impact. It will never come from your area 1 to area 3 to area 2 to area 1. Okay, so how many areas you can create in OSPF? You can create in 0 to 4.2 billions of area. 0 to 4.2 billions of area. Right? Now, whereas 0 is known as backbone area and all other areas are known as regular area. 1 to 4.2 billions of area. They all known as regular area. Only area 0 is known as backbone area. Do you guys know about this or not? What is the work of a backbone area? Anyone? Guys, you have already learned CCNA. You should know at least this. What is the work of area 0? Backbone area. What is the difference between backbone area and a regular area? Yes, anyone? Anyone? Fast. Just try. At least try.
So each OSPF network must have at least one backbone area, that is area 0, and other non-backbone areas must have connected to backbone area.
Very good. Okay. For what? For what? Why a regular area will connect to a backbone area? Why? Try. At least try. So that I will come to know how much you guys know about the OSPF. If you won't talk, then how come I will let you know how much you guys know? At least talk. Yes. What is the concept? Like why the regular areas are connected to a backbone area?
To area 0.
Very good. Yeah. Continue.
Correct, if I'm wrong, it could be the link state advertisement, like both areas connected.
Link state advertisement. Come again. Link state advertisement. That is known as what? LSA. What exactly the LSA is? LSA is an OSPF packet type. LSA is an OSPF packet type which exchange your network information from one router to another. Okay, let me explain you what exactly the backbone area is. Okay, backbone area is the area which connect two regular areas with each other. That means backbone area have the authority or have the compatibility to receive a route from one regular area and give it to another regular area. Okay.
So your voice is breaking.
The voice is breaking. 1 second, let me check the internet. Hello. Now is it clear to everyone? Hello.
Yes, sir.
Okay, is it clear now? Okay. So what exactly the area is? Area 0 is the area which is known as what? Backbone area. Okay, which exchange your IP packet from one regular area to another regular. That means what? It have a capability to exchange or to receive a route from one regular area and give it to another regular area. That is why it is known as what? Backbone area. Backbone area. Secondly, the regular area. Regular area is the area which exchange their information within an area, within an area. For example, if you will see, okay, these two are the regular area. One is known as area 1 and the second one is known as what? Area 2. Now, area 1 is a regular area. Similarly, area 2 is also a regular area. Whatever information will generate from regular area number 1, whatever information will generate from area 1, it will remain within an area 1. It will never cross its area boundary router and reach towards area number 2. Similarly, area 2, whatever it will generate, it will remain within an area. It will never cross its area boundary router, okay, and never go into an area number 1. Okay. If you want a communication between area 1 and area 2, so what you guys should have? You should have area 0 between all those areas. You should have area 0,
It is
which is
breaking
known as
a
what?
lot.
Breaking a lot. Hello. Hello.
I can hear you.
Okay. If you want a communication between two different regular area, you should always have a backbone area between two regular areas. Okay, So now what it will do? Okay, this is what area 0. Area 1 will exchange our network information or whatever it's a packet type. It again.
Yes, sir.
Why sometimes it is like you stop speaking. This is what kind of hearing.
Hello. Is it clear now?
Yes, sir. We can listen you now.
Okay. Let's just change the internet. So you guys understand about the regular areas. Okay, regular area where information will remain in same area only. Okay, if you want a communication between two different regular areas, you should always have a backbone area in middle of two different regular areas, two or more different regular area. If you want a communication between them, you should always have a backbone area in between them. Okay, so what they will do, area 1 will exchange their information with area 0. Okay, similarly area 2 will exchange information with area 0. Why? Because it is known as what? A backbone area. Now backbone area will do what it will do, it will exchange your area 1 information with area 2 and area 2 information with what? Area 1. Okay, so like this, two different regular areas will going to communicate with each other, but not directly, with the help of what? Area 0, which is known as what? Backbone area. Okay, so what exactly the definition of a tell me.
So, sir, you're saying that in any topology, the backbone area is necessary. It should be there, even though it's area 1, 2, 3, whatsoever. But we still need a area 0.
Every time, each and every regular area should have a directly connectivity with your backbone area if it wants to communicate with all other areas. Got it?
Okay, sir.
Okay, any area, if it want a communication with any different regular area, it should have a direct connectivity. It should have a direct connectivity with the backbone area to make a communication with all other regular areas. Okay, so for example, let me show you one example. Here it is like this. All routers are directly connected to each other. Okay, in this topology, you have configured the OSPF, and in OSPF, what you have done, okay, these two router of this network you have put in area number 1. These two router you have put in area number 0, area 0. These two router are in area number 2. These two router or a network which is in area number 3. Okay, so by this topology, what do you understand? Which are the areas who are going to communicate with each other? See, this is what the backbone area. This is what the backbone area, which will collect information of a regular area, area number 1. Similarly, this is the backbone area, and this area 2, which is directly connected to backbone. Okay, area 0 will collect information of regular area 2. Okay, and it will exchange with whom? 1. And one information it will exchange with whom? 2. Okay, now what about area 3? Does area 3 will communicate with any other area in this topology? Any other area in this topology? Regular area, this router. Okay, what regular area says? I will never cross my area boundary router to reach on any other regular area. It's not saying about backbone area. It's not saying about backbone area. What it says, I will never cross my area border router to reach on any other regular area. That means area 3 will never communicate with area 2. Area 2 will never exchange its information with area 0. Then area 0 will never exchange that information with area 2. That means in this topology, all routers are configured with OSPF. But then also this area 3 network will never ever able to reach any other OSPF router. Any other OSPF router. Okay, why? Because area 3 will never advertise in any network, never advertise any network to any other regular area which it is directly connected. Okay, if you want this area 3 should have a connectivity with all other regular areas. So what it has to do? It has to make a direct communication with the backbone area. It has to make a direct communication with the backbone area. Then backbone area will collect that a regular area information, and also it will share with every other regular area. That's the point.
But if we talk about this topology, those are connected state with a line. So how exactly the route area boundary router 3 that is going to be communicate with the boundary router?
Area boundary router. Okay, simple. Okay, it should have a direct connectivity. Okay, if you don't have a direct connectivity like this topology, you don't have a direct connectivity. So there is a concept. There is a concept in OSPF known as what? Virtual link. In OSPF, there is a concept known as what? Virtual link. You will create a virtual link from here to here. Okay, so what OSPF will understand? If it is virtual or if it is physical. But you should have a direct connectivity, it says. Okay, so you will create here a virtual link between area boundary router of area 0 and area boundary router of area 3. Okay, so what they will understand? They will understand like they are directly connected to me now. Okay, then only the communication is possible. Else, if you are not using a concept of a virtual link, so area 3 communication is never ever possible with every other area. There is a concept known as virtual link that we will see.
So can we consider this topology as a ISP network? Like we can call it area 1 as a ISP1, area 2 ISP2, and the 3 is the ISP3 and the boundary router. Still, yeah, would that be possible for these routers to communicate with each other if they are not sharing virtual?
If they are not using a virtual link concept.
Yep.
Yeah, you mean to see this? You mean to say that?
If we consider all three areas or 4 areas, including the boundary router areas, area 0. So I was a little bit confused about the area 3. So let's say if we consider area 3 is not our network, not under the our administration.
See, I work for a network, okay, where we have configured the OSPF. okay, where I am working, okay, there we have configured OSPF network. Okay, what exactly we guys are using is, let me show you that. Okay, we have multiple locations. We have multiple locations. Let me explain. This is my hub location where we guys are sitting in North. This is known as what, hub location. Okay, we have multiple areas. We have multiple areas somehow like this. Different cities we are connected. Okay, so this is my city X, this is my city Y, and this is my city Z. Okay, all the branches which are in city X, they all are using the same areas. Okay, so you should have a connectivity somehow like this in OSPF. If you are considering OSPF as your routing a protocol in your topology. Okay, all the router in area or location X, okay, they all are using the same area, then only the communication is possible. Similarly, whatever the router which is in area, or sorry, in location Y, they all are using the same areas. Similarly here also, what they do, they will never exchange their information like this. They never exchange. They always exchange their information with the backbone like this. Okay, even if you have a direct connection over here, okay, then also they won't communicate via this link. Why? Because this is not possible in OSPF. Okay, as compared to our previous topology, if your area 3 is connected behind the area 2, the communication is never possible until and unless you will use a virtual link between them. Got the point?
Yes, sir.
Okay.
So before moving forward, I have another question related to
Tell
the
me.
multicast
Multicast
address. Yeah.
224.0.0.5.
Yeah, 5 and 6.
5 and
And
6.
where exactly we are going to use the 5, and where
See,
or the router is going to use the 5 and 6?
OSPF use or OSPF support a different types of network, which is known as what? Point-to-point network. I think you guys have heard about it. Point-to-point network. One is known as point-to-multi-point network, whereas previously we guys are using a technology known as what, the frame relay technology. There we used to configure a point-to-multi-point network. Okay, point-to-point network, point-to-multi-point network, which is also known as hub and spoke topology, DMVPN. Okay, and one is known as NBMA network, non-broadcast multi-access network, and one is known as what? BMA network, broadcast multi-access network. Broadcast multi-access network. There we have to do a selection of DR and BDR. Have you guys heard about it? DR and BDR, designated router and backup designated router. Anyone? Yes, Adnan? Have you heard about it? DR and BDR, designated router and backup designated router.
So I heard about it, but I really don't remember the concept of a DR and BDR right now.
Okay. So in OSPF support a different types of network topology. Okay. One is known as what? Point-to-point network. Point-to-point, where a router is directly connected to another router using a single link. Okay. And one is known as what? Point-to-multi-point network. Okay, where one is the hub and multiple are the receivers. Okay. Third one is what? NBMA. NBMA means what? Non-broadcast multi-access network. Non-broadcast multi-access network. Now, what exactly it is? Okay, non-broadcast multi-access network means what? Okay, you have a switch. You all guys know about the switch. Switch is what? A multi-access device. multiple users are connected and accessing each other. Okay, there you have a connectivity somehow like this. OSPF routers are connected. Now in here, users are not connected. OSPF routers are connected. And all the routers are connected in a different network. Okay, listen me properly. All the routers are connected in a different network. Like this one is connected in a network of 1.0. Second one is connected in a network of 2.0. Third one is connected 3, and the last one is connected in 4.0. Okay, so what do you guys think? Does broadcasting is possible? Like if 1.0 will sell, you can say like if 1.0 will send any information, by default it will reach to 2.0 or not? No. Why? Because switch will never make a communication between two different networks. Okay, we understand. It is a multi-access network device, where all users or all router can communicate with each other. Okay, but here two different networks are not able to communicate with each other. Okay, so this type of a topology is known as non-broadcast multi-access network. Non-broadcast multi-access network. Okay, if what this guy is using a IP of 1.1, second one is using an IP of 1.2, third one is using the IP of 1.3, and the last one is using the IP of 1.4. That means all four routers are connected within a same network. So now what will happen? Broadcasting will happen or not? Broadcasting will take place. Why? Switch will make a communication between all the routers. Which will make a communication between all the routers. So this is known as BMA network, broadcast multi-access network, where all the routers are able to reach each other by default without any protocol. In previous topology, NBMA network, communication is possible, but all are connected into a different network. So there we need what? A routing protocol. Until and unless you want to put a routing protocol, they want to communicate to each other. But here in this topology, routing protocol is not needed. All router will make a communication with each other. Why? Because all are connected within the same network. So broadcasting will happen over here. Okay, so in this topology where broadcasting is happening, to compress those broadcasting, or to, you can say like to manage that broadcasting, they use a concept of DR and BDR. One router will elect as a DR and the other one will elect as a BDR, backup designated router, and all other routers are known as DR other routers. One router will elect as a DR, which will have a control on complete broadcasting. If this router will dies down, okay, BDR will take a place of DR router. So what they do? They create a BDR also. In future, if DR will not reachable, to whom we should make a communication? So they make a secondary router, which is known as what? Backup designated router. Okay, so whenever a DR will exchange any packet, all routers should know that this packet is coming from a DR router. So they use a special address which is known as 224.0.0.6. So whenever a DR will update to every other router, they will exchange information with 224.0.0.6 with a special IP address. Okay, so whenever other router will receive a packet with an address of 0.6, they will confirm like this information is coming from DR router, designated router. Okay, but in every other case, hello, please keep your mic mute. But in every other case, like in point-to-point network, in point-to-multi-point network, in NBMA network, where broadcasting is not happening, okay, there they will use an address of 224.0.0.5. Okay, in only special case where you have a BMA network and there is an election of DR and BDR, there only DR is responsible to send a packet with a special address of 0.6 to 24.0.6. Any doubt?
So can you please explain again the 0.0
0 dot?
5? How exactly 0.5?
See, in point-to-point network, if you have point-to-point network, okay, the basic topology of OSPF, point-to-point network, there they will always use a address of 224.0.0.5. Is it clear now? Okay. Similarly, if you have a point
Yes,
to
sir.
multi-point network, they will use a simple multicast address of 224.0.0.5. Same if you have a NBMA network, they will use 224.0.0.5. But in a case of a BMA network where a DR and BDR election take place, where a DR and BDR election take place, there every routers gets an update from a DR router. From where it will get the updates? From DR router. Okay, so whenever a DR router will exchange a update to every other router in a BMA network, okay, they will use a special address of 224.0.0.6. Okay, then only every other router will come to know this information is coming from a special router, that is a DR router. Why? Because it is coming with an address of 224.0.0.6. Got the point?
Yeah.
Hello.
Tell me. Hello. Hello. Is it clear? Hello. 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 Our voice is clear?
Yes, sir.
I hope the area concept is clear. OSPF packet types, LSA. What are the packet types in OSPF? What are the packet types in OSPF? How many different types of a packet in OSPF? LSA, link state advertisement.
11, I believe.
No. Inside LSA, there are different, total 11 different types of LSAs. Okay.
6.
6. Can you please tell me the name?
Hello packet.
Hello packet, very good.
Database description packet.
Hello packet, very good. Hello packet and
Database description packet. DVD.
DVD, database description packet, very good. Okay.
Link state update.
Link state update packet.
Link state request.
State request. Link state.
Update LSU.
LSACK. Link state acknowledgement.
LSU. Link state request.
LSU.
Link state update. Link
Very good,
state
very
request.
good. Let me make into the sequence. Okay, so similarly in OSPF also we have 5 types of different packets. Okay, and they are what? Hello packet, DBD packet, link state update, link state acknowledgement, and link state request packet. Okay, hello packet which is used similar same like EIGRP. Hello packets are used for what? Neighbor discovery.
Yeah, never discover.
Okay, database description. Yes. Routing information. Okay, link state update. If any update happens, why? Because in here also update is what? Incremental update. Update is incremental update. Incremental same. If anything, if any increment will happen, then only a router will exchange their information with a neighbor router. Same like EIGRP, not like RIP. In RIP, what it does, it use a periodic update in every 30 seconds. It will update to its neighbor router. Okay. Here, no. Here it is what? Incremental update. Whenever a new information will come, then only a router will exchange that information with a neighbor router. Okay, so that it is exchanged with the help of what? Link state update. Okay, so your neighbor router will acknowledge you with an link state acknowledgement packet. Okay, if any information is missed out, your neighbor router will send you a request with an link state request packet. Link state request packet. Last packet is what? LSA. Link state LSA. Link state acknowledgement. Link state acknowledgement
Acknowledgement.
or advertisement.
Provide the confirmation.
Huh?
Provide
the
the confirmation.
No, I am asking to you. Is it acknowledgement or it is advertisement?
Acknowledgement, sir.
LSA.
Yes, sir.
Advertisement.
So what is
Advertisement.
LSACK? What is LSACK then? This is link state acknowledgement, ACK. Okay. This is what? Link state advertisement. Link state advertisement.
Yes, sir.
Okay. Link state advertisement. It will advertise your link state. It will advertise your link state. Okay. There are 11 different types of LSS. Can you at least name those 11 different types of LSS? Can anyone? At least five. What are the LSS in OSPF? At least 5, which are regularly used. At least 5. The first one.
So we have the Type 1, which is the router LSA.
Very good. Type 1, which is router LSA. Type 2,
network LSA.
very good. Network LSA. Type 3, yes, come on. Type 3,
Summary.
very good. Summary LSA. Okay. Type 4, yes, come on, come on.
Sir, ASBR LSA.
Very good. ASBR LSA. Type 5,
Multicast.
multicast. What multicast?
Multicast OSPF LSA.
No. Anyone else? Type 5. Type 5. Yes.
Autonomous system external LSA.
That is 4. Autonomous ASBR LSA. Type 5. External summary LSA. Yes. Come on. Type 6. Yes. Yes. Type 6. Nobody knows? Okay. I
That's
also
the
don't know.
multicast.
Yes, tell me.
Multicast.
Type 6.
That's the multicast.
Multicast OSPF LSA.
Very good. Multicast OSPF LSA. Type 7. Yes. Very good. Come. That's true. N. Starting from N.
Not so stable, not so NSA.
Not so stable area LSA.
Not so stubby area LSA.
Very good. Starting with N. Not so stubby area. Not so stubby area. This is a special OSPF area type known as what? Not so stubby area. Okay, there are special areas in OSPF. Till now, we have seen only two different areas. One is what? Regular area, and one I explained is backbone area. Okay, there are multiple different special areas in OSPF, NSSA, and stub area, totally stub area, NSSA area, totally NSSA area. Yes, is it or not? Stub area, totally stub area. That we will learn. NSSA, type it. If you guys will stop, I will also stop. Yes, type it. Come on.
External attribute LSA for BGP.
Basically, it is known as GPLSA. That is it. Okay. For external, yeah, it is of course for external attribute LSA for BGP. Okay, but in short, we know we tell us like a BGP LSA. Yes. Type 9. Yes. Type 9. Type 9. Opaque LSA. Type 10 and 11 for future upgradation. Okay. Type 10 and type 11 does not have anything that they have kept for future upgradation. If anything new will happen in OSPF, they will come up with a type 10 and type 11. Okay, type 9, which is known as opaque LSA. Okay, that we never use in OSPF. We never use opaque LSA. Okay, starting of 5 are very important to understand. Okay, type 7 also is important, but not in every case we use NSS. Okay, so starting the type 5, which is important to understand. Okay, so make sure next time whenever you will come, you should have at least 1 point with those 5 LS. At least 1 point. Okay, and what are those LSSA? Router LSSA. Okay, network LSA, summary LSA, ASBR LSA, and external summary LSA, which is known as what? Type 5. Have you guys seen the table of OSPF? OSPF routing table? Have you guys seen OSPF routing table? What I have written? O routes, OIA routes, OE routes. Have you guys seen the routing table of OSPF? O routes. What are the different routes you guys can see in OSPF routing table? What are the different routes are there in OSPF routing table? O routes are there, OIA routes are there, OE routes are there, OSPF route, OSPF inter-area routes, and OSPF external routes. Okay. In our next session, we will see routing types of starting for LSA. Okay, at least one point from LSA, starting of LSA, which is what? Router, network, summary, ASBR, and external summary LSA. At least I want 1 point from you guys. At least one. Okay. And what are the types of routes in OSPF routing table? What are the types of routes in OSPF routing table? Okay. Any doubt till now? Whatever I have explained you today. No doubts? Okay. That's very good.
Yeah, okay. Or the OIA.
Okay. So goodbye for today. Tomorrow same time. Okay. Thank you everyone.
Okay, sir. Thank you.